Alright, since we're talking about exponents, let's consider what happens when we have an exponent that's not an integer, but a rational number. That's what I'm stating here, b to the n, where n is an element of the set of rational numbers. Now, I think you've had this as far back as Algebra 1, but we'll go ahead and quick review. If the square root of a is equal to b, this implies that b squared is equal to a. Principal square root here, so we're looking at a and b being greater than or equal to 0. Now, this is true, then what I want to do is I want to take this and I want to square both sides. I'm going to square the left side and the right side. If I square the left side, I get this. If I square b, I get a. Now, a is the same as a to the first, but I'm going to think of the square root of a as a to a power. Now, if I have a power to a power, that means I multiply the exponents. And if the bases are the same, the exponents must be equal. So that says x is to the 1/2. X equals 1/2. So the square root of a is equal to a to the 1/2. You can have an exponent that is a rational number. For a positive integer n greater than 1, the principal nth root of a, denoted the nth root of a, is a number such that the nth root of a is equal to b, implies that b to the n is equal to a. If n is even, then a and b are both greater than or equal to 0. And you say, well, what does this have to do with rational exponents? They're tied together, and that's coming up. But real quick review, when you see this symbol, the little number that's tucked in there, that's the index. Now back here, I didn't have an index written down. That's considered a square root. The 2 doesn't have to be written down, it's implied. The expression that's underneath the radical sign here, the radical sign being the symbol, is called the radicand, and of course this symbol is the radical sign, although some textbooks say that this part is the radical sign and that this is just like a symbol of grouping. It's what you're taking the root of, the nth root of. This textbook considers the whole thing the radical sign. So let's simplify these 5 expressions here, and then we'll tie together how these nth roots and rational exponents correspond. So for the first one here, I am looking at the cube root of negative 125. You don't have to put the little corner on there, that's just a little bit of flair. The cube root of negative 125, it has to equal something. Let's say it equals b. Well, if that's true, then negative 125 equals b to the third. What number times itself is equal to negative 125? Well, that's negative 5. Negative 5 times negative 5 times negative 5 is negative 125. Notice, if you have an odd index, you can have a negative number under there and it's still considered a real number. If you have an even index, well, we'll see that in just a second. B. We have the square root of 144 over 121. Now, the fraction underneath the radical sign would normally cause us a little bit of difficulty, but both the numerator and the denominator are perfect squares. This is 12 times 12, and this is 11 times 11. So what fraction times itself is 144 over 121? Well, that would be 12/11. So I can kind of do that one in my head. A little bit tougher to do in your head with the decimal is the 5th root of 0.1234 zeros and a 1. Tenths, hundredths, thousandths, 10,000, 1/100,000th. The 5th root of that. Well, I'm looking for a number times itself, times itself, times itself, times itself. That's going to give me this really small number. Now I know when I multiply with decimals, I have to add decimal places, so I'm thinking that this is probably 0.1. Now the only way you can check it is to multiply 0.1 times itself, times itself, times itself, times itself, or just go ahead and punch it out on a calculator, and you'll see that indeed is 1/10. Remember, this is 1/100,000th. 10 times 10 times 10 times 10 times 10 is 100,000. I think I did 5 tens there, I hope I did. The next part is the 6th root of negative 64. Here's where I have a negative number as a radicand, but I have an even index. This is no good. This is not a real number. So if this happens and you have to indicate what this simplifies down to, you can just say not a real number. Now, even though the last example is similar looking, it's not the same because the negative is outside the radical, and this is the opposite of the 6th root of 64. Well, the 6th root of 64 is a real number because that's a positive radicand. So I'm thinking to myself, what number times itself, times itself, times itself, times itself, times itself is going to give me 64, and fortunately it's 2. This is 2 times 2 times 2 times 2 times 2 times 2. So this is the opposite of 2, or negative 2. And that's my answer. Okay, so what we have here are something that we started looking at in the last part, and that is that we can have a rational exponent. We said that the square root of a was equal to a to the 1/2, which leads us to believe, to maybe generalize, I should say, that a to the 1 over n is equal to the nth root of a, and that a to the m over n is equal to the nth root of a to the m, that's not a times m, a to the m, or the nth root of a, all that raised to the m. These guys you should remember from your Algebra 1, Algebra 2 days. Here's a bunch of properties that go along with them. The bottom is kind of showing you how it's equal to both parts here, and that if you have something raised to the m over n power where your numerator and denominator are not necessarily ones, that it can be written into this form or into that form there. I kind of like these two guys right here because when you take the nth root of u and you raise it to the nth power, well, that's kind of an inverse effect, and we should get right to the radicand. But not necessarily the case down here. Notice the stipulation that the nth root of u to the n is equal to the absolute value of u of n is even. I'll give you a for example. If I have the fourth root of negative 2 to the fourth power, well, that's not going to equal negative 2 because this is a principal root. It's an even index. So this would be the fourth root of negative 2 times negative 2 times negative 2 times negative 2, or positive 16, and that's a positive 2. So you have to be a little bit more careful here based on the index being odd or even. And everything else is pretty explanatory, that the nth root of a product is the product of the nth roots, and the nth root of a quotient is the quotient of the nth roots. So let's use that right over here. I have 36 to the 1/2 power. For part A, that's the square root of 36, better known to its friends as 6. Over here, I have the 1 over 125 to the 1/3 power. Well, that is the cube root of 1 over 125, which is the cube root of 1 over the cube root of 125. Well, 1 times 1 times 1 is 1, and 5 times 5 times 5 is 125. This is 1/5. For the third one here, I have negative 9 to the 1/2 power, which is the square root of negative 9. Not a real number. Remember, if you have an even index, and the index is 2 there, we don't put the 2 down because square roots are the most common type of root, but it's understood that it's a 2 there. If you have an even index, you're not for the real numbers anyway, you're not taking an even index root of a negative number. For D here, I have negative 1 to the 4/3. I can approach this either way. I can write this as the cube root, that's the denominator, is the index, of negative 1 to the 4th power, or I can write this as the cube root of negative 1, all that to the 4th power. It's going to work either way. Negative 1 times negative 1 times negative 1 times negative 1 is 1, so this is the cube root of 1, which of course is 1. Over here, this is the cube root of negative 1, which is negative 1 to the 4th power. Well, negative 1 times negative 1 times negative 1 times negative 1, you got it, is positive 1. So that works either way. Last but not least, with the negative exponent in there to throw it in on top, you have negative 125, this is for part E here, to the negative 2/3. The first thing I'm going to do is I'm going to write this as 1 over negative 125 to the positive 2/3. Then I'm going to do the index first. I am going, because I don't want to square 125, I'm going to take the cube root of negative 1 over 125, and I am going to square it. That's the power, that's the index of the root. Well, what number times itself? Well, I just did this, or almost exactly this a minute ago. The cube root of 1 over 125 was 1/5. The cube root of negative 1 over 125 is negative 1/5. And then that gets squared, and a negative times a negative is a positive, and that's 1 over 25.